Hello my friend, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have very interesting, in the same way tricky and relaxing algebra question: x to the fourth power equal to x minus 4 to the fourth power. And a lot of students might be saying, hey mister, this is very easy question, we can easily solve this question in a few seconds, we can easily cancel this fourth power from both sides, and as a result on the left side we will get only x, and on the right side we will get x minus 4. We're gonna cancel this x, and as a result what you can see right here, we have 0 on the left side equal to minus 4. And a lot of students confused about this expression, and they ask, how can we solve this question correctly, how can we solve this question step by step? So right now you can easily test your school knowledge, you can easily write your answer down into the comment section, and we will check your answers here in just a few seconds. It will be really interesting. So first of all, let's bring this expression from right side to left side with the negative sign. Let's do this right now. So as a result we have x to the fourth minus x minus 4 to the fourth, x minus 4 to the fourth equal to 0. Right now we have a difference of fourth powers, but we can easily express this x to the fourth power as x squared to the second power, and we can easily do the same thing with this expression. So we can easily write it as x minus 4 to the power 2, and let's use this type of brackets right here, and we're gonna raise these to the power 2 equal to 0. So it changed nothing for us, because according to a basic math property, whenever we have expression with, for example, the structure like a to the power x raised to the power y, we can easily multiply a to the power x times y. So we can easily multiply 2 times 2, we have the same 4. We can easily multiply 2 times 2, we have the same 4. So nothing changed for us. But right now let's consider it from another angle, because we have a difference of two squares. For example, this is our a, this is our b, yeah? And we consider it as a square minus b square, and this is all known formula from school. Everyone know about this formula, I think. So we have a square minus b square. This is our difference of two squares. As a result, this is equal to a minus b times a plus b, all known formula, a plus b. Right now let's apply this formula right here, a equal to x squared, b equal to x minus 4 to the second power. So let's write it as a product. So let's start from the left side. As a result, we have the first one with the negative sign, so we have x squared minus x minus 4 to the second power, and we have the second parentheses, x squared plus x minus 4 to the second power. So we just write it, we just factor it in terms of this formula. What are we going to do next? Right now let's simplify this a little bit. First of all, we can easily raise this to the second power, both expressions. So let's do this right now. As a result, we have x squared minus, don't forget about parentheses. So as a result, we have x squared minus 8x and plus 16. This is our first parenthesis, and the second parenthesis right here we have x squared, the same thing but with the plus sign. So plus, we have x squared minus 8x and plus 16 equal to 0. Right now let's open parentheses real quick. We can easily do this because we have not a hard expression, to be honest. We have sorry, we have x squared minus this one. We can easily write as this x squared with the positive sign because we change it, so plus 8x and minus 16. Okay, after first parentheses, and in the second parenthesis we have all the same thing because we have positive sign before these parentheses, so we don't need to change this sign. Okay, x squared plus ax squared minus 8x and plus 16. Let's simplify this a little bit. As a result, what do we have? We can easily cancel this x squared, and in the first parenthesis we have only 8x minus 16, so 8x minus 16 in the first parenthesis. In the second parenthesis, what do we get? 2x squared, we can easily add it, so we have 2x squared minus 8x and plus 16 equal to 0. Really great. And if you look closely right now, we factor our question and we have a product of two parentheses. The first parenthesis multiplied by another one, and of course equal to 0. So it means that the first parenthesis is equal to 0. So let's split it by two parts. For example, we are talking about the first equation, 8x minus 16 is equal to 0, and the second equation, or 2x squared minus 8x plus 16 is equal to 0. Right now, for example, let's solve real quick our second equation. This one, for example, let's divide both sides by 2. When we divide it, we will have a greater equation for us. We have x squared minus 4x and plus 8 equal to 0. Right now let's find the discriminant real quick, and let's plug in each of these elements into all known spot. So right now let's write that a equal to 1, b equal to minus 4, and c equal to 8. Right now let's plug in into all known formula. First of all, we can easily find real quick our discriminant equal to b squared minus 4ac. So let's plug in first of all in discriminant. So we have b minus 4, so we have minus 4 square minus 4 times a times 1 and times c times 8 equal to, so our discriminant is equal to 16 minus 4 times 8, we have 32. So our discriminant is equal to minus 16. So it means that at this point, in this second case, we have complex roots because discriminant is less than 0. So from here it means that we have two complex roots. So let's find it. Let's find all of these roots right here. First of all, let's plug in this thing into this spot. We all know this formula. So right here, for example, we will have x first. At this point, we will have x second and third equal to, we have minus b plus minus square root of discriminant and all over to a. Let's plug in each of these elements into this spot. So we have minus b minus 4, yeah, minus 4 plus minus square root of discriminant equal to minus 16, yeah, minus 16, and we divide all of this stuff by 2 times 1. We can easily simplify this real quick. Minus 4, we have 4 plus minus square root of minus 16. Let's write this square root of minus 16 as square root of minus 1 times 16, okay? And we divide it by 2. Right now we need to remember a really great property. I'm going to write this property right here at this point. Whenever we have a square root of a times b, we can write it as square root of a times square root of b. So we can easily split it, yeah? As a result, we have 4 plus minus square root of minus 1 times square root of 16 all over 2. Really great. So as a result, we have 4 plus minus square root of minus 1 equal to I, square root of 16 equal to 4, and we divide it by 2. And right now, the very tricky move, a lot of students don't know this tricky move, because right here I'm going to divide a numerator by parts. So I'm going to divide 4 by 2 according to a common denominator, and plus minus 4i divided by 2. And we can easily cancel this 4 and 2. We can easily cancel 4 and 2 right here. So as a result, our answer is 2 plus minus 2 plus minus 2i. So these are our two complex roots. Right now, let's go back to this point. So right here we have 8x minus 16. From here, 8x equal to 16. And from here, x first is equal to 16 over 2. But we can write it as 2. So x first equal to 2. It looks like we solved this question. We find all of our roots, and right now let's write our final answer, and we can easily check our answers real quick. Right now we can see a graph. You can see this point of intersection, so we can see this answer from geometric perspective. You can easily do this. So x first equal to 2, you can see this point of intersection in terms of real numbers. X second, let's look with the positive signs of 2 plus 2i, and of course x third equal to 2 minus 2i. So these roots are complex roots. This one root is real root, so real root. So this is root in terms of real numbers. Right now, let's check this root real quick. So we don't need to check this complex one because it will be like a long video. But x first equal to 2, let's check it real quick. So our question looks like that: x to the fourth power equal to x minus 4 to the fourth power. Let's check this x first equal to 2. So as a result, we have 2 to the fourth power equal to 2 minus 4 to the fourth power. Really great. So 2 to the fourth power on the left side. On the right side, we have inside parentheses minus 2 to the fourth power. And here's the tricky moment. It's not the same expression right now at this point. But if you look closely, we can easily write, instead of this minus 2, we can easily write minus 1 times 2 to the fourth power. We can easily write like that. And we can easily raise this minus 1 to the fourth power and 2 to the fourth power. Or I won't show you another way, but let's look at this one. So we have minus 1 to the fourth power, because we're going to write for minus 1 to the fourth and 2 to the fourth. So we have minus 1 to the fourth times 2 to the fourth. And minus 1 to the fourth, because we have even numbers, so this is only 1. So as a result, we have 2 to the fourth equal to 2 to the fourth. This is a great proof when you have a huge value, huge numbers. But at this point, you can easily write that 2 to the fourth equal to 16, I guess. So we have 16 equal to, of course, 16. So you can easily write it. You can easily prove it like that when you have a huge power. So step by step, you eliminate this negative sign. And of course, when you have 2 to the fourth, we can easily write that this is equal to 16 at any point. Okay, so it was my explanation about this question. I really hope you understand it. I really hope you enjoyed this video. It's extremely important for me when you leave your response into the comment section. It's extremely great to see your response, to see your answer, to see your solution, and I really hope your solution is the same as mine. But definitely don't feel bad if you got this wrong, and forget about this canceling force power. So when you have x to the fourth equal to x minus 4 to the fourth. So forget about this canceling for power, because you can easily do this, but don't forget about absolute value. And of course, with this proof, you will have only real number, root when you solve this question with absolute value. Okay, so you will have only a real number root, but don't forget about complex root, which is really important thing. If you cancel this first power, don't forget about absolute value. This is extremely important part at this point. So thank you everyone for your time. Wish you all the best in your life. You can also write your response down into the comment section, write your notes down into the comment section about this challenge. I really appreciate it. I really want to say thank you everyone for your support. It's extremely important for me. Wish you all the best in your life. Take care of yourself and have a great day. See you in the next videos.